Now we want to see where this is equal to 0 or undefined, just like we did for the first derivative test. We're just applying the same logic to the second derivative, which will give us different information. It'll give us information about concavity and inflection points instead of increasing, decreasing, and relative extrema. We know that e to the x is not going to be 0 like we described before. So it's all about this factor here. Okay? So let's just examine that factor momentarily. We have x squared minus 2x plus 2 equal to 0. So we want to solve that. So we should try to use the quadratic formula because it doesn't look like it's going to factor very well. You can take a quick glance and see that. So this would imply, right over here maybe, x equals negative b, that'll be a positive 2, plus or minus the square root of b squared, so negative 2 squared, minus 4, 1, 2, 4ac, right? That'd be an 8. All over 2 times a, which is 1, so just 2. All right, we don't need to go any further. We see 4 minus 8, right? We see that the discriminant is negative. So therefore, there are no solutions, no real solutions, and all we're dealing with in this class is real numbers. There's no complex numbers whatsoever. So therefore, if the discriminant is negative, we know there's no real roots to this equation and no values that will make, no real values that will make the second derivative 0. All right? Now, where will the derivative be undefined? It'll be undefined at 0 again, just like it was for the first derivative and just like it is for the original function. All right, so again, let me just make this caveat. So even though, what do we know? We know that f double prime equal to 0 has no solution. And we know that f double prime undefined leads to x equals 0. But this cannot be a possible inflection point because the original function doesn't exist there. Right? But nevertheless, it's possible the function changes concavity here. I'm not saying it does or doesn't. We'll find out in a second. But it's possible it does. So it's still important to the sign chart we're going to create in a second. But even if the sign of the second derivative should change around 0, it does not make it an inflection point because there's no function value there. It has to be an inflection point, a point on the curve itself. If there's no point for the curve, then even though it may change sign, you will not call it an inflection point. So let's make the sign chart and see what's going on. All right, we only have one value to put on, that's 0. So let's see what happens. If we take a value less than 0, we'll test negative 1, for instance. We put negative 1 back into the second derivative, right? It's most, you might say, most pristine form here. So this factor is always positive again, so we don't have to even think about him. But the sign of the second derivative is controlled by two different factors now. So when x is negative 1, for sure x cubed is negative. Okay, so he's negative. But what's going on here with x squared minus 2x plus 2? If I put negative 1 in, I'll get 1 plus 2 plus 2. Looks like it's positive. Okay, so this factor would be positive. Let me just move this down a little bit so it doesn't confuse the reading here. And that factor is negative. So when I test negative 1, I overall get a negative second derivative. So therefore, on this interval, it's concave down. Now we'll test a value to the right of 0. We'll test 1. Just pick easy numbers. I put 1 in here. This factor on the bottom is now positive. The factor up here is 1 minus 2 plus 2 is still positive. Still positive. So therefore, the overall value of the derivative, the second derivative, is positive. So therefore, the original function f is concave up on this interval. So now we know about the concavity. It is concave up on 0 to infinity. It is concave down everywhere else except 0. oops, I wrote it up, concave down on negative infinity to 0. And there's no inflection points. For the reason I explained before. That even though there is a change of sign for the second derivative at 0, and there is a change of concavity there, but 0 is not in the function's domain, there's no point there for there to be a point of inflection. Matter of fact, it should be an asymptote.